Okay, we're looking at the Unit 1, Lessons 10 through 12 practice quiz today. The first question talks about composition of functions. The first few questions actually are about composition. So for number 1, it says we need to find f composition g and g composition f if they exist. So basically when you're doing composition, the place that you're starting from is the second letter that's listed. So we're starting with f composition g, we're starting with the g function. Looking at the first point, if we put in 0, we get out -9, and then you're taking this output and putting it into f as the input. So when I output -9 for g, I input -9 for f, and I get out -1. So my point that's in the composition is 0, -1. And you can see that here. For the next one, if I put in -1, I get out 3. Then I put 3 in, I get 4. So -1, 4. That's my second point. Then again, for the third point, we'll end up with 4, 0. For g composition f, this time we're starting with f. So if I start with -9 and I get out -1, then I put -1 in down here and I get 3. So -9, 3 is my first point. And then you go through and you do the rest and you'll get these other 2 points in the g composition f. For question 2, we're doing the same type of thing, except we have actual functions that are defined for us instead of just a set of coordinate points. So we're doing g composition h first. So that means I'm going to take the h function and plug it into the g function. So my h function is 2x plus 3, and I'm plugging that into the g function in place of the x. So I would have had -8x for g, but instead of x, I'm putting in the 2x plus 3. Then I distribute the -8, and I get -16x minus 24. For h composition g, I'm starting with g function, which was -8x, and I'm putting that in place of the x on the h function. So I would have had 2x plus 3 for h, but instead of this x right here, I'm putting the g function in -8x. 2 times -8x is -16x, and then plus 3. Question 3, one more composition problem where we are plugging in a particular value into some of the functions. So we have h of g of -3. So what that means is that we need to put -3 in the g function first, and then whatever answer we get, we're going to put that answer into the h function to get our final answer. So g of -3 would be 5 times -3, because the g function is 5x. 5 times -3 is obviously -15. So we're putting -15 into the h function, h of -15. That would be -15 plus 4, which gives us -11. So our final answer for h of g of -3 is -11. Question 4, find the inverse of a relation. The inverse of a relation just flips the x and the y points. So instead of -3, -7, we'd have -7, -3, and then I went through and flipped all the other points. Question 5, find the inverse of the function, then graph the function and its inverse. So our function is g of x equals 3 plus x. In order to do the inverse, you're going to flip your x and your y. So I'm changing the g of x into just being y. So then I flipped them and I got x equals 3 plus y. To solve for y now, I want to subtract 3 from each side, so I get x minus 3. And instead of y, I'm going to say g inverse of x. So this is my inverse function. When I graphed it, my original equation, g of x equals 3 plus x, that's just a line with a y-intercept of 3 and a slope of +1. So I labeled it g of x. And then my inverse function is another line, x minus 3, with a y-intercept of -3, so I'm down 3 spaces. My slope is still +1, up 1 over 1. Connect it, make your line. I put a little notation here to show that this is g inverse. And I also drew my symmetry line as a dotted line just so that you can see really clearly that these lines are symmetric. My function and my inverse function are symmetric around this line of symmetry. You can see that they're equidistant at every point from this symmetry line. Question 6 says, determine whether each pair of functions are inverse functions and write yes or no. So in order to be inverse functions, two functions f and g, what you have to do is take the composition of them, do f composition g and g composition f, and each time that you do that you have to end up with just x. So what I did is I started with f composition g, so I'm starting with g, negative 2x, and I'm plugging that into the x on the f function. So for the f function would have been 2 times a number. That number is negative 2x. 2 times negative 2x is negative 4x, which you cannot simplify to any further, and so it's not equal to x. And so because this composition is not equal to x, I know that these functions aren't inverses. They are not inverses. You don't even have to check the second one if the first one already doesn't fit the rule. Question 7 says the Clearys are replacing the flooring in their 15-foot by 18-foot kitchen. The new flooring costs $17.99 per square yard. The formula f of x equals 9x converts square yards to square feet. Part A, find the inverse, and then what is the significance of the inverse for the Clearys. So I changed my f of x to just being y, so I had y equals 9x. I flipped x and y, got x equals 9y, and then I solved for y, so I divided both sides by 9. So I got my inverse function, f inverse of x is x divided by 9. And so what the inverse does, it told us that the formula converts square yards to square feet, so the inverse would flip these concepts. The inverse converts square feet to square yards. Part B, what will the new flooring cost the Clearys? So now I have a formula that tells me how many square yards a certain room is going to be. So I know that their kitchen size is 450 square feet just by doing 15 times 18. And my formula says that I take the amount of square feet and I divide it by 9 to get the amount of square yards. So 450 divided by 9 is 50 square yards. And the flooring costs $17.99 per square yard. So I just multiplied 50 by $17.99 and I got $899.50. So the flooring cost the Clearys $899.50. Question 8. We need to graph the function, state the domain and the range for y equals negative square root x minus 1. So the first thing I'm looking at here is the shift, and I'm basing that off the formula that was given in the notes. And so I see that this graph has been shifted right one space, and it was not shifted up or down. There's no k value at the end. So my domain is any x value greater than or equal to 1. And my y value, my range is any y value that's less than or equal to 0. The reason this is less than is because I have the negative sign in front. So I'm looking at the bottom half of a root function. The negative root starts at a point and goes down. So my range is less than the starting value. To get these points here, did the same process we thought about in class. If x is 1 up here, 1 minus 1 is 0. I know the square root of 0 is just 0. After 0, the next square root I know is 1. So if I use 2 as my x value, 2 minus 1 gives me 1. The square root of 1 is 1. That gives me negative 1 because of the negative sign in front. For 5, if I put 5 minus 1 in, I get 4. I know the square root of 4 is 2, so negative 2. And you can see here, there's a pattern of negative 1. That pattern shows up as the a value in your equation, which would be right out in front of this negative 1. So then I just graphed these points. Obviously 10, negative 3 didn't fit on my picture, but I was able to graph 3 points and still get a good idea of what the graph is going to look like. Question 9, we have an inequality, but still a root function. So it says y is less than or equal to square root of x minus 5 plus 3. I pointed out, just to make sure I remembered when I graphed, that because of this inequality sign, I'm going to making a solid line because of the equal sign, and I'm going to shade below because it's less than. My shift is right 5, up 3, so that's my first point on my table. And then I used 6 because 6 minus 5 is 1, and I know the square root of 1. I used 9 because 9 minus 5 is 4, and I know the square root of 4. I used 14 because 14 minus 5 is 9, and I know the square root of 9. When I plug each of these x values in, I get 3, 4, 5, 6. So again, I'm not going to be able to fit 14, comma 6 on my graph because this graph only goes out to 10. But I put the first 3 points on and was able to make the shape. I drew a solid line and I shaded everywhere below the graph. Make sure you do your shading. Make sure you are aware of the type of line you're making anytime you have to graph an inequality. And the last question on the quiz. It says the velocity of a roller coaster as it moves down a hill is v equals the square root of v naught squared plus 64h, where v naught is the initial velocity and h is the vertical drop in feet. If v equals 70 feet per second and v naught equals 8 feet per second, find h. So I'm plugging in these values in my formula that they gave me. V is 70, so I'm replacing this v with 70. I'm replacing v naught with 8. So that gives me 70 equals the square root of 8 squared plus 64h. I squared both sides, so that gave me 70 squared, and it removed the square root sign on the right side. Then I squared out these numbers. I got 4,964. Then I brought the 64 over here, so I subtracted 64 from each side. That gave me 4,836, and the last step is I divided by 64 to get h by itself. And that gives me, when I divide this on my calculator, 75.56, and my units of height are feet. And that's the whole quiz. Make sure you use this to help you self-study for the quiz that we have coming up in class on lessons 10 through 12.